Great. Thanks, Michelle, and everyone in the room and online. Yeah, great to see the room so full for this. So I'm going to talk about the OICR Genomics program, and then the other leads of each of our departments are going to really drill into some of the details. So I'm going to give you that high-level flyover, and then we'll really get into the weeds of how to work with us and what we can do and how we can best collaborate together. So I almost always have this as my first slide. We're a whole genome shop, so we do everything comprehensively, complete sequencing whenever possible. So whenever we're looking at a technology, the question is always, is it comprehensive? So we like whole genome and RNA sequencing specifically because it's up to 50 tests, but one assay. You just run it once, and a lot of our validations are actually around bioinformatic validation and benchmarking against other clinical or other research tests that already exist. So I put up this figure really just to show actually a pretty short list of the type of rich information that you can derive from a single whole genome and RNA-based sequence. And we're actually one of the only labs in the world that actually clinically reports whole genome and RNA sequencing as one integrated test, focusing specifically on somatic variation. But you can see a lot of the other things that we can call out here. HLA, we're currently validating. Some algorithms to look at cancer neoantigens is a very big research interest. And as those research studies get really mature, we want to work with you to onboard and ideally include those on our clinical reports. The other reason we like genomes is they're always informative. They age really well. You sequence everything. Even if you're we actually had an inquiry the other day, really interested in one gene, and that's actually very hard for us to do. We're actually much better at doing exomes and whole genomes, and it's almost in some cases more cost effective to sequence everything and then just look at that one gene rather than try to come up with a way to focus just on one section. This plot is sort of a patient's journey. So the y-axis is tumor burden, and we're very active in all these areas. I'm going to talk a lot about and share a recent success story in early cancer detection. A lot of our work is done just cancer landscapes. Tumor is manifest. What are the drivers? What do you find in the DNA and in the RNA? A lot of our cell-free DNA work is in that crash down to minimal residual disease. Is it a crash down to zero? Is there still residual disease? And a lot of really innovative clinical trials now are looking at debulking surgery. Did that surgery work? And it's a question we actually hear from patients as well. Am I cured? Are there cells there? How can you quantify any sort of minimal residual disease? And a lot of our work is done in the final two bumps, which are often in clinical trial space. So after standard of care, use exactly the same technologies and exact tests, but answer totally different questions in the clinical trial arena. So we really have three mandates. I mentioned comprehensiveness, but it's really broken into three broad areas. Technology access, so how do we bring on the latest and greatest technologies? Looking at technologies really quite critically, and similar to diagnostic development, getting those in-house and benchmarking them against technologies that we already have validated. Research catalysts, this is working directly with scientists. Same sort of thing, taking a research-grade protocol or piece of software and professionalizing it and productionizing it. Not as easy as it sounds. You can't just check out a piece of software and start running it. This is often a multi-month, sometimes year-long process to productionize the research assay. And clinical implementation, which we've already talked a lot about, supporting especially prospective clinical research trials. So groups that will pick up those reports like PanCure that Alinka described. We really want as many studies like that as possible, because in my opinion, that's actually where we're learning the most. That is that real-time knowledge feeding back to clinicians, and also looking at outcomes and clinical data as they receive a genome-informed treatment. Also building on Linka's talk, volumes are skyrocketing. So in the last year, we processed over 17,000 libraries, a lot of those coming through a tissue portal, over 5,000 patients on. I really want to get to 100 research studies. I think we'll probably do it this year, if not next. This has a massive storage footprint. So this has given us a lot of hard thinking around what is our data retention strategy. And our data retention strategy is get it back to the collaborators as soon as possible. We're not a data warehouse, and we're really shortening up our data retention and getting it right back to the collaborators. This also includes a direct pipe to data sharing systems like CBio Portal or the European Genome Phenome Archive, which is a huge free archive for genomic data that provides controlled access to your data. And we have a whole protocol and team who's able to help you with that transaction. You finish a project with us, but we'll also help you share your data in a safe way. We talked about CLIAS. That was our final accreditation we just received earlier this year. We landed the NovaSeq X Plus, which I'll just talk about on the next slide. We actually coordinated this purchase with UHN. These are big multi-million-dollar machines, and we strategically wanted to have a huge increase in sequencing capacity to really pair up with the intensified research activity we saw around whole genome sequencing. I'm going to talk about OICR East, which is further scaling that capacity beyond just University Avenue and out across the entire province. It's been a collaboration with Harriet Filotter in Queens, and cell-free DNA sequencing. So I'm going to talk about how our cell-free DNA approach is actually quite different from a lot of the targeted approaches that have really had a lot of traction up to this point. Here's a visualization of our just straight up basis sequence, and you can just tell by eye. There's, if not for the pandemic, it would just be this power increase. But it's not just it's not like the number of samples are increasing on a power curve, but the depth and the scale of the profiling for those samples is. So we've really moved away from panels, away from exomes, and really to whole genome sequencing. And this really rationalized our need to expand our sequencing capacity. So I talked about the NovaSeq X Plus. This is sort of the newest version of the Illumina sequencer. So we use this NovaSeq 6000. This particular one's dressed up for Halloween. It's now sitting next to two NovaSeq X Pluses that, just by these bar graphs, give us a big decrease in reagent costs. This is the other reason for the uptake of genomes, is they're way cheaper now. The runtime's way faster. We can basically do a run, churn out multiple genomes in a single day. We don't really measure them in genomes per hour, but that's kind of the scale. I'm not going to promise you a 2.5-hour genome, but I'd love to get there. And there's a lot of other infrastructure that are around these devices. So a big investment in robotics. We can start doing whole genome sequencing libraries in a plate, and then a huge amount of upfront QC. And this really came through in Alinka's talk, how important those quality gates are at every single step along the way. So rather than just do a very expensive sequencing run, we do a really low pass run on all of our sequencing libraries, verify that they have cancer cells. Sometimes they don't, so we'll stop, and make sure that the library quality is sufficiently good for us to push to deep whole genome sequencing. The other unique thing about our environment is this blended RUO clinical workflow, and it's really the only way that we can support these prospective research studies. A lot of the clinical research, you get this very slow drip of 2 or 5 or 6 samples a week, but we are operating at scale. We need to do hundreds or ideally thousands of samples a week. And this is really where we've blended and harmonized our clinical pipelines to look exactly like our RUO pipelines. So if you request an RUO genome, we treat it like a clinical genome. You get all the same quality gates, and you get all the same bioinformatics as well. So the way this bioinformatics worm diagram works, you start with the reads coming off the sequencer. So there's genomes and RNA-seq. You go through all these algorithms that are engineered on our high-performance computing cluster. And what most people care about are the blue boxes. So you get a list of mutations, you get an inference of cancer cell content or purity, you get a copy number profile, you get the exact same content that you'd have on our clinical test, but you get it as a researcher to do a much deeper dive than what we would do for the clinical report, which is really just focused on actionable variants. So that's really where we're able to do that split of, here's the clinical report you need today, but here's also all the nuts and bolts for doing your research study to find the biomarkers for tomorrow. I mentioned our cell-free DNA strategy being a little bit different. It was really motivated by this actually my favorite paper of 2020 from Dan Landau's group, really this paradigm shift away from targeted sequencing, looking at single mutations, and instead just sequencing the entire genome and looking for hundreds of thousands of mutations across the entire genome. And the analogy here is a hockey analogy. Instead of trying to sharpshoot out a single mutation, throw 10,000 pucks on net. You don't need them all to go in. You just need enough of them to be there for you to infer the presence of disease. And this nice little statistical model sort of sealed it for me. You need very deep multi-thousand X coverage to find a cancer signal, whereas going this 10,000 mutation route, you can be much more sensitive, and you have the potential to become even more sensitive with further bioinformatic techniques. So you don't have this physical limitation of just running out of mutant molecules because you're looking at so many mutations genome-wide. So this is what this looks like in the real world. This is a patient with multiple myeloma, and we had blood samples taken over time. We also had their multiple myeloma cancer genome sequenced as part of one of the clinical studies at Princess Margaret, led by Suzanne Trudell. You can see kind of exactly what you'd expect. At diagnosis, the detection rate, which is still low but statistically significant, is much, much higher at diagnosis. When they're successfully treated, that cell-free DNA signal crashes down, in this case, not really to zero. And then you can see sort of this ebb and flow and really complete concordance with what we saw from actually a quite invasive, painful serial bone marrow test. So the serial bone marrow test showed disease, minimal residual disease negative and then positive. And we can actually see this using a much more palatable blood test over time as well. And you can see in this case, we're tracking 11,000 mutations, but you can also call out the drivers at that diagnostic site as well, because the level of disease is so high. So you get all the benefits of whole genome sequencing, but you can also be extremely sensitive. The other reason we like whole genome sequencing for plasma is it cuts across every single cancer type. We don't have to set up a panel for every single disease area. We can run one test for absolutely everyone. So if you show up with 1 or 2 samples, that's okay, because you just join the pile of other research studies that also have 1 or 2 samples. So it's very operationally efficient for us. So speaking of other studies, it was really exciting to see communities across Canada applying to this Canadian Cancer Society Team Breakthrough Grant. We actually participated in multiple of them, and actually 4 of the 10 that were funded are all being run through the OICR Genomics program, really focused on clinical whole genome sequencing and minimal residual disease detection. And you can tell just by the names of the titles and the PIs and the disease areas, totally different scientific questions, but all using the same genomics platform for us. They're all going to feed us a few samples at a time, but by aggregating them all together, we can really make sure that we get these clinical reports back quite quickly. So this does bring up the problem, even though we do have a coalition of 4 NovaSeq sequencers, 2 here and 2 at UHN, I suspect we're still going to run out of space. This is just the nature of this business. Especially when we have a platform, there's lots of work to be done. And certainly we saw this when we were discussing with Harriet Filater and Amber Simpson at Queen's. They actually also have a sequencing center at their place. So we thought, let's have genomes all done in a consistent way across the province. This has been an issue in genomics really historically, especially as each group set up their own non-comprehensive assays. This is a chance to do whole genome and RNA sequencing the exact same way. And that's really around this thinking of OICR Genomics East. Agree on a quality framework and a set of protocols, and then distribute that to all other labs. So even if you're in Queens or London or anywhere else in the province, Ontario genome is an Ontario genome. And this is sort of a work in progress, but that's really what we're thinking. And it's not just the quality framework, but the SOPs, the bioinformatics, really distributing everything that we do as much as possible. So why would we do this? This is actually to span really 2 translation gaps that move from basic to clinical side to from basic to translational and into clinical practice. We've been very active on the left-hand peak for a very long time, just supporting basic research. Our clinical accreditations have really helped us get into the clinical science area. We don't aspire or want to be a standard of care lab, which is sort of the right-hand peak, but we do want to enable the movement of technologies from our translation environment into the hands of hospitals that are doing high throughput routine testing. And that's really the point of this Ontario Genomics program. Can we expand that framework, not just to other research genomics groups, but also to other clinical labs that want to rapidly adopt whole genome and RNA sequencing and potentially other comprehensive assays. And this is my last slide. This is what we want to share. So if anyone's sort of interested in this concept, you have a sequencing group, or you'd like to participate in whole genome sequencing, this is what we want to share across as many groups as we can, coordinating sequence capacity. Our sequencers are full, yours are empty, or vice versa. How do we seamlessly move libraries and samples and capabilities around? SOPs to deliver this. Let's do whole genomes in the same way. A single LIMS and software development enterprise. So really around how do we write software around interpreting and returning and QCing a genome. And ultimately, we're all in the service delivery business. We want to be very transparent about how samples come in, what's happening to them. The genomics program is not a black box. We have a lot of protocols on exactly how we operate. And how do we return that back to collaborators who really are just looking for a seamless experience, sample in, genomics out. We want to make that as easy as possible. And on that topic, I'll turn it over to Carolyn, who will tell us about our quality management.
Hi, I'm Carolyn Patak. I'm the Senior Program Manager and QA Lead for Genomics, and I'm going to discuss our accreditations and our quality management system. So everyone keeps showing these 3 certificates. We're very proud of them. We're accredited by 3 internationally recognized organizations. So that's CAP, CLIA, and Accreditation Canada Diagnostics. These are our accredited assays. We have whole genome sequencing and transcriptome sequencing. You can get it as a complete package, or you can just get the whole genomes by themselves. We also recently validated plasma whole genome sequencing. So this is an add-on to the initial tumor whole genomes that can be used to detect MRD. And we have 1 targeted panel, that's the Revolve panel. There are a lot of benefits to working with an accredited lab. So first of all, you know that you're going to get a certain standard of quality. When you get your clinical report, you're also going to receive a QC audit trail report. I'll talk about that in a bit. Our deliverables are clear from the start. They're derived from our validation experiments and specified for each assay. We also have clear turnaround times. So that's 45 days for whole genomes and transcriptomes and 21 days for targeted sequencing. There's also guaranteed retention times for your reports and for data. So in Ontario, clinical reports are held for 10 years, and the data used to generate those reports, plus all the other QC data that we accumulate in the testing process, that's all held for 2 years. All the staff that will perform your assay from extraction all the way through to informatics and report sign out undergo a strict training program that's all defined in SOPs. They have regular competence testing, and we have proficiency testing for each assay. So that's normally an external test that's run once or twice a year to ensure the assay is performing appropriately. We use a secure portal for sample submission and for return of reports to you. So you enter your PHI in the portal. It's disassociated from the entire lab testing process and then reassociate at the time of clinical reporting. So you have any concerns about data privacy, that takes care of that. And we also regularly assess customer satisfaction. It's a part of our ISO compliance, but if you work with us, we'll take your input very seriously, and all of our assays were built to meet customer needs and to address changing customer needs, which is in relation to point 7 here, we are required to continuously improve, and we do. We pay a lot of attention as to what can be improved with every assay, and we iterate as needed. So the quality management system, this is the heart of the operation. It's ISO 15189 compliant, which is the medical laboratory standard. This basically defines all the requirements that a molecular lab needs to function efficiently. And so I've already talked about the accessioning system, training, PT. We have nearly 100 SOPs to which we adhere very strictly. We have a lab information management system, some quality gates that I'll discuss on the next slide. We manage inventory to ensure that all your reagents are in appropriate quality. All of our assays, our clinical assays, go through a very detailed validation process to address sensitivity, specificity, accuracy, and reproducibility. We have a corrective and preventive action system. So anytime there's even a minor deviation from an SOP, we capture it, mitigate it, control it, and then prevent it from recurring. All the equipment and the lab environments are tightly monitored and controlled and documented. Once a month, we have a lab inspection. Once a quarter, Trevor comes in and does a director lab inspection. We have an internal audit once per year, and each of our accreditation organizations audit us every 2 years, but they're staggered. So every year we receive an external audit as well. And these are our quality gates. All the metrics at each gate are derived from the validation experiments. And like I said, when you get your clinical report, you will get an audit trail as well to see how your cases have performed at every step. So Tissue Portal performs the first 2. They receive the samples, inspect the packaging, make sure that everything has arrived intact. At the extraction gate, we measure yield. At the library preparation gate, we're measuring things like fragment size distribution, adapter contamination, as well as yield. At the shallow whole genome sequencing stage, this is basically just to prepare for the in-depth sequencing, but we're inspecting insert size, duplication rate, performance of 5x control, sequencer metrics. The same goes for full depth sequencing. And then at the pipeline and interpretation stage, so looking at things like tumor purity, callability, trimming. And then when it gets to the final report stage, this is where the geneticists, so normally Trevor, usually always Trevor in this time, but eventually someone else will review the audit trail to ensure that the samples have passed at every step and make sure that the calls are logical before releasing the reports. And we do offer research assays as well. They're almost identical to the clinical assays, as Trevor mentioned. There are a few differences. So the clinical assays do have a very long, 70-some page formal validation. There's a proficiency test associated with them, normally external, sometimes internal if no external exists. They use the REC system, they have the guaranteed turnaround times, and at the end you get a clinical report. But the research assays, some benefits of those are the flexibility. So, if your coverage is 1x or 0.5x below our cutoff for the accredited assay, you can choose to override that in a research assay and we'll go ahead. There's a larger variety. We can offer you a research exome or molecular inversion probe assay, and they're more adaptable. So a new technology comes out and we can immediately put a research assay on there. We're running research assays on the NovaSeq X right now, but the clinical assays have to go through a long amendment process to ensure that they're comparable to our existing technology. But the star in the center here, these are all the things that are the same. The QMS, the metrics, they use the same lab environment, same equipment, same staff, same limbs. The inventory is managed the same way. We measure key performance indicators for everything every year. The RUO assays are not directly audited, but because there's so much overlap with the clinical assays, they are essentially audited and they all follow the same project life cycle. So if you want to work with us, step one, go to the website. You could take a look at all of our services. Under services and resources, we have the pricing menu with all of our service list and price menu. It's always up to date and the date of last update is on there. And then there's this work with us tab, which outlines the entire process for project initiation. Then there's a link you can click to contact us with your details and we'll send you an estimate. We're working on updating this, so there's an auto quoting system that should really decrease the time to initiate a project. But for now, an email to us will suffice and we'll get you started. So I'll pass this to Bernard now. He's our Associate Director of the Translational Genomics Laboratory.
Thank you, Karen. And thank you, Trevor, for actually giving us the introduction. And all the time, actually, I think that you can see your patient samples, and at the end of the day, you see your patient's report. But what happens in between, sometimes you may not actually envision. So today, actually, what I want to do is just give you a quick overview of how the lab actually looks like, and especially actually in our CAP-clear accredited lab. So again, as Karen mentioned, we are a fully accredited sample to data high throughput NGS lab. It is fully ISO 15189 clear CAP accredited. We are equipped with state-of-the-art genomics and next-gen sequencing instruments. And more importantly, we actually have a team of highly qualified professionals with a very diverse background from both academia, industrial, and clinical backgrounds. So this actually enables us to do a lot of different things. And currently our capacity is about 3,000 cancer cases per year, which is actually not like your standard kind of whole genome cases. This is actually like an ultra deep sequencing, 100 exactly for tumor, 40 for normal. And with the uptake, with the installation of NovaSeq X Plus, we basically have the capacity of going up like almost double the potential actually cases. So before we put actually all these samples onto the sequencer, there's actually a lot of work to be done. So try to quickly go through that actually, and you can see actually some of the pictures, especially those actually who may not be able to go on the tour today. So we're going to give you actually like the kind of what kind of equipment we have. So again, if you go to our lab is unidirectional. So we have samples that is extracted from a tissue portal, as Lincoln has actually mentioned. They're actually on the 5th floor of OICR. And this totally separated from my team. And they will walk over the sample over to us, our DNA samples. But we have also two labs, two rooms in the lab. One is actually temperature-free for allocating reagent, and then the other one is basically for all the library prep and sequencing activity. So it's unidirectional so that we actually avoid minimum contamination. So we can handle different types of DNA and RNA samples. So we have validated lots of our protocol on fresh frozen, FFPE, and liquid biopsy, specifically cfDNA. We can do high throughput sample processing. So if you look at actually the top right corner, there is a 96-well ultrasonicator for shearing DNA. And then, on the top left corner, you have a multiple 96 capability quality control instrument. And then bottom right is the couple of our high throughput liquid handler. To the left is the Hamilton, to the right is like a Covaris. So actually, I can have one. And of course, actually, one of the things that I always want to point out actually is that our lab is fully accredited. So, we always have to put our certificate up there so that we make sure that, not only that actually we want to show everyone who comes in or the inspector coming, I think that our team actually take that with pride and really actually kind of maintain that high standard actually all the time. So again, as I mentioned, of course, actually, we also have a full kind of line of Illumina instrument. So the top picture is really kind of like just give you an overview how the lab actually kind of looks like. As Trevor kind of already kind of mentioned, we actually have a full line of next-gen sequencing instrument. They are mainly Illumina sequencer. We have 3 MiSeq that is actually for quality control. And then we have a NextSeq 550, and then also just recently installed a NextSeq 2000. They are not only for quality control, we're actually going to transition all quality control over, but also actually, like say, we are doing actually like quite an array of kind of analysis before we move on to the no-physics sequencing. So with the library quality control, we actually can do, we are kind of introducing swap detection in that, and eventually also, we also actually have been actively doing a tumor content estimation actually through shallow whole genome sequencing. And of course, actually also we have some clinical assay that is actually using these mid-throughput sequencers. So some of our clinical targeted sequencing is being actually sequenced on the NextSeq. Of course, finally, we do have actually 3 NovaSeq, 1 6000 and 2 X Plus. Again, I'm going to put myself in a little bit of trouble, but we do have actually the first X Plus in Canada. But also actually at the same time, actually, we also have 2 X Plus right now. So we're basically the only lab in Canada that have 2 X Plus, unless actually Illumina has to correct me on that. I think, okay, good. All right, it's good. Just want to be sure. All right. And again, if you have your opportunity to stick around for a tour, we'll be more than happy to show you actually our facility. That's fancy, but not. I think that the really important thing for this team is a very unique actually position that we are. We are a accredited lab in a research facility, which is actually very, very important in that sense. Just remember that all our, like as Carol has mentioned, all of our clinical study has undergone vigorous assay validation. So kind of like on the right-hand side, you can kind of see actually our normal process. It's actually like what we're doing almost every day. Is that, if we want to introduce a new assay, we have the assay design, and then we go through a very tedious assay validation process, including like, a bunch of sensitivity, specificity tests and whatnot. After that, we generate data, we have to basically do the data analysis, but also at the same time, this is not the end of the story. We actually have to kind of write up the SOP, we actually have to write up the validation report in preparing for our audit, right? So at the end of the day, Trevor, as our medical director, he will sign off all the reports. So all the assay that we call it clinical has to go through these kind of actually long process. But that actually is a very important for us to guarantee quality days in and days out of what we are offering. And I'm just going to show you like an example here is like our kind of like validation report for each of these actually, it will be like 50 to 100 pages usually actually what you're going to see. So now that being said, right, we are in a research institute, so that means that we actually also support basic research. So the good thing with us is that all our RU offering basically are done at the same level of our clinical offering. So, and also as Karen mentioned, they also carry out in our accredited space. So again, we actually hold our standard of our RU assay, the same standard of clinical assay, except that we don't give out a clinical report. So again, at the same time, actually all lab staff undergoes like documented training for each assay and also periodic proficiency testing. So that's kind of like an introduction of like how our lab operates. Just quickly, actually, before I close out, just a quick few slides to show you what our capability and what kind of assay we offer. So kind of, I think you heard quite a bit of that. Our kind of bread and butter is the whole genome transcriptome sequencing assay. So this is fully accredited under CAP clear ISO. And our classic kind of like default offering is a deep 30x normal 8x tumor, 100 million whole transcriptome. We do have a turnaround time of 45 days. The clinical report was signed off by our medical director. We have our offering, same production pipeline, except actually we can also offer different actual coverage. The assay is validated for both fresh frozen and FFPE sample. Some of the technical detail, if you're interested, definitely are already listed actually there. We also do clinical targeted sequencing. This is mainly through a Revolve panel, a very small panel with some hereditary cancer gene probe in there. Same thing, clinical report available, and turnaround time is 21 calendar days. It's validated for not only the solid tumor tissues, but also we have validated for cfDNA. Got the technical detail again at the bottom. And then we also have some RUO targeted sequencing offering, including whole exome and cancer panel. These are all using the IDT Xgen capture chemistry. One of our newest clinical offering is plasma whole genome. So this is using about 10 to 20 nanogram of cfDNA and produce the whole genome library and sequence them at 30x to 40x depth. And these are validated for MR detect for monitoring tumor content in a liquid biopsy. Again, same thing, we have an RUO offering, and you can use, like, I think teams like Trevor's team, for example, has been looking at additional kind of parameters such as fragmentomics. Lastly, we do also have quite a different array of different kind of research heavy kind of assays. So we have the SNP assay, which is in collaboration with one of our OICR PRs, Abelson, and this is a homebrew method that they developed, and we're able to offer it specifically for a myeloid panel. And then we definitely have a lot of work and collaboration in the methlome. I think you already heard some from Philip's group, but we have been helping actually many local researchers on methlome study, including CF-MEDIP, which is basically an antibody-based capture high-throughput sequencing using actually a 5MC antibodies. But also we have been rolling out, and I think there's a lot of uptake, which is using the enzymatic methyl-seq assay, EM-seq. And this is for the whole genome level identification for both 5MC and 5HMC. And the very important thing is this single nucleotide resolution. So, and the thing is that we kind of the EM-seq currently over bisulfite is really more for that there's less DNA degradation of that, and we also have already validated a method for using DNA as the input. So especially in the old days when whole genome level methlome sequencing can be quite expensive with the onboarding on instrument like X Plus, that really drive the cost down. I think that's now actually a lot of people are looking into these type of actually assays. Finally, to close off the lab operation, I think just want to kind of repeat a couple of points that actually my colleagues have stressed, but I think it's actually really important that kind of demonstrate our kind of boiler occurring in the team. So again, we are the sequencing center for the Marathon of Hope PEPM2C, Princess Margaret wing of this national program. And for those who may not are familiar with the Marathon of Hope, it is actually a joint effort to build 15,000 cases of cancer patient whole genomes data with clinical data within 5 years. And then other clinical trials, and some of those actually Trevor will mention a little bit about it. And we actually have been involved in a number of clinical trials, including CHARM, which is actually Trevor actually is one of the major PI on that. We also actually have ovarian cancer trial, and also as the link has actually mentioned a little bit. We have been actually heavily involved in some of the pancreatic cancer trials. All right, that's for me, and I'm actually passing on Larry, actually our Associate Director for Genome Sequence Informatics.
Thanks, Bernard. Okay, I'm going to talk about a lot of what I'm going to talk about right now has already been alluded to by Linka and by Trevor and the other genomics team. But I'm going to tell you about the people who are kind of building a lot of the tools and software that kind of makes all this happen. The Genome Sequence Informatics group is under genomics. It actually consists of 3 distinct teams that do different things, but we work very, very closely with each other. The infrastructure team really is involved with building a lot of software tools that's really oriented towards doing a lot of the tracking and running the analysis that people have talked about already. And part of that is automation. We're very focused on running things very, very consistently and with a very defined turnaround time, and automation of a lot of these processes is key to that. The analysis, that team is run by Mike Loslowski in my group. The analysis team, the Beatrice, is kind of working in that infrastructure and building up a lot of the analysis pipelines, doing workflow development. But in addition to, they're also managing the pipeline. So as things run through, we do want to make sure things run through without error. If errors do occur, we want to be able to address them quickly and efficiently, and make sure things kind of pick up and move forward. And also involved with both data release and data deposition, which I'll cover shortly. And finally, the third team is the interpretation team under Alex. And they're also involved in pipeline development, workflow development, kind of handing it off to the analysis team for implementation. But their key roles are really in the validation of our pipelines that go into the clinical report generation. So first, the infrastructure team, I'm going to mention a number of software tools that have been built with funny names and have been mentioned earlier. MISO is really key to a lot of what we're doing. It's our LIMS system. I'll mention a lot of this software has been developed after using other tools to kind of address these purposes and realizing there were limitations or we needed to make this work better and kind of integrate everything with everything else. And MISO is one of the solutions that came about of using an older LIMS system that just wasn't working. We decided to go at it ourselves. It's an open source LIMS system, other people can use it. And we are actually involved in making this available to other people by providing support both for installation, training, and feature development if that's required as well. It's been mentioned about the genomics program, which is going to be making use of LIMS, our LIMS system, and we have other people who are interested in it as well. On top of it, kind of our infrastructure is really based on using what's available to OICR in general, including our high performance computing cluster, which has over 8,500 cores and about 10 petabytes of storage. This, however, is a shared resource across the institute. We kind of use a large part of it, but we do have to make sure our systems are using it efficiently. As well as it is maintained by our IT group, as well as our OpenStack virtual machines, where we build a lot of these software tools are kind of running on those systems as well. Our pipelines are managed by 2 tools, VR, which is the workflow management and tracking system. And under that, we're really running our workflows through an open source workflow engine developed by the Broad Institute with Whittle workflows. And we also have Shesmu, which is our decision-driven action launching system, which basically manages the launching and kind of ensuring that things, looking at all the data that's available, and the right things are being launched at any one time. Our most recent effort, this is going to be mentioned several times, but not by name, is DIMSUM, which is a QC tracking dashboard. People have mentioned the various quality gates that are being used to watch data going through the system. This is really a tool that's under current development. We're currently in a second phase of development to kind of make this available to all users of these systems, so they can kind of really keep a close eye and make sure things are processing through the laboratory and analysis as expected. Trevor's mentioned this as well, kind of the growth in data. We've gone from about 60 terabytes back in 2017 or so, but 2012, I think, to about over 400 terabytes of data being used each year. And that's only growing with the new sequencers that we have. And this is a big component of what we're dealing with right now. More workflows being executed as well. The ability to manage all this really is dependent on lot of the software that we developed. And our current focus with respect to the amount of data that's being produced is to make sure we're managing the footprint of the data, getting it off to our recipients quickly and not kind of consuming space. As we've often done in the past, we kind of learned a lot of lessons from it on how to move forward. And it's becoming very important as we move forward with these new sequencers. Pipeline development, here's kind of another picture of the whole genome transcriptome pipeline, which you've seen already. We offer a number of analysis packages that are really tied to our service offerings. There's effort to expand these further and kind of add more analysis packages. But some of the service offerings that really don't have analysis at this point. You can go to the website, see details about what's currently available and information about exactly what's run in each case. As mentioned, we're using WDL as a workflow description language. All of our workflows are freely visible to review on our GitHub repos. There's a link there. The development of these workflows is really dependent a lot on best practices, both internal, but also looking at best practices for a lot of the tools that we're running, and making sure that we're learning lessons from there and running in a similar way. And a lot of our focus is really on efficiency, both in terms of research usage and turnaround time. These workflows are developed to run well, and there's a kind of a continuous reconsideration of how we're running these things and how we can improve them, especially as we kind of make efforts to decrease our turnaround time. Most of our software is open source that we use, and as mentioned, these pipelines do go through validation for clinical reporting, and those validated pipelines are also used for RUL. Endpoints here are the clinical reporting reports that go out and data delivery to the RUO objects. Also mentioned, we do provide some other services, which were mentioned earlier too, putting data to CBAR portal from our whole genome transcriptome pipeline. But as well, we've developed some good tools for putting data to the European Genome Archive. This is developed out of work a number of years ago with the ICGC project, where we put a lot of data into EGA and figured out some methods to kind of make it work a bit more efficiently. It's not a simple process. This will really automate a lot of the work of both putting the data up there and registering that data as well. And we work, I'll mention as well that we, in addition to kind of the service offerings that we have for our laboratory offerings, we do have a bring your own data module where we can kind of take data coming from other sources, putting it into our system, running it through our pipelines, but also addressing these needs as well. The interpretation team, as I mentioned, we're involved with the report generation. This is kind of a schematic of how that works as a requisition system, which our infrastructure team is also involved with in terms of building and maintaining. And this is kind of the portal for which requests for the clinical reporting assay come in. It holds the PHI data, which is kind of filtered and not made available to systems within GSI. But it's kind of a mechanism by which that information can be entered in, ultimately moved to the clinical reports. Data will go from the requisition system, we're putting onto the metadata into another resource that was developed by the interpretation team called Jerba, which will allow review of the data from various sources, both from the requisition system, but also from our analysis and from our LIMS system to generate a report that can ultimately be reviewed and signed off and returned back to the requisition system. You've seen some quick pictures of this already, our clinical reports. These are developed by the interpretation team. A lot of effort has gone into this, and these are under continuous review and further development as new assays, maybe new metrics are added to it. We have the turnaround time, as mentioned, of about 45 calendar days. This is from end to end, going from sample prep all the way to reporting, with a final review and sign off by the medical director. This is our whole genome transcriptome report, but we are developing other reports as well And I'll just kind of close off by mentioning our most recent offering, kind of finalized at the end of the summer. The cell-free DNA plasma whole genome report for detection of residual disease. And that's mostly in place right now, but still subject to further development. Okay, with that, I'll pass it back over to Trevor.
Great, thanks, Larry. So I just wanted to show just some super new data, just really putting all this machinery you've heard about into practice. And this actually paper was just accepted days ago, so I was very comfortable talking about it, and that's our CHARM consortium. And it's specifically using our cell-free DNA test in individuals who are at extraordinarily high risk of developing cancer. So these are carriers of pathogenic variants of P53, ERCA, Lynch syndrome. They're born with sort of that first cancer gene, and they come in every single year for a surveillance visit, usually imaging and a medical exam. But what we hear is that frequent enough? And we hear many anecdotes where no hint of disease 1 year, and a year later they come back with a tumor, sometimes metastatic. So what's happening within that year interim? And so we had the cell-free DNA platform. This really felt like a real opportunity to make a difference in how these cancers are surveilled. So we founded this consortium called the CHARM Consortium. You can see it's a linkage of many of the cancer hospitals across Canada, a layer of translational research groups, including OICR Genomics, that's doing all the genomics testing, and then multiple funders really focused on different types of hereditary cancer. And the story the data I just want to show is sort of our experience specifically in Lee-Fraumeni syndrome. So led by Raymond Kim looking at the adult P53 carriers, and David Malkin at Sick Kids looking at the pediatric P53 carriers. So this paper is probably going to come out next month. It's been accepted by Cancer Discovery, and it's really looking at these serial blood draws before these individuals ever get a cancer diagnosis. So I've just shown here the results from our CF mediate methylation assay and then a genomic assay. So this is a combination of an aggregate score of copy number alterations and point mutations. You can see there's 2 blood samples here, both negative, and here's their surveillance scan. So these individuals get whole body MRI, which has its own access issues. It's highly centralized. You have to come to basically downtown Toronto to get your scans. So everything makes sense at this point. We had many ways to look at cell-free DNA. Everything is negative and imaging is negative. Not the case for the next 2 blood draws. So in this case, you see an uptake just creeping over the threshold here for the methylation score. We also found a copy number change, and then a subsequent blood draw also had a point mutation detected as well. So they still hadn't rolled around to their next surveillance visit yet, but indeed there was a leukemia detected, and this leukemia detected, and you can also see the cell-free DNA signal also really starting to take off. So really, the opportunity with regular clinical cell-free DNA profiling start to find some of these tumors early. We had a large cohort of 89 patients. Very similar story across many of them. But the other take home was it's not just mutations or not just copy number, not just methylation. Some individuals had tumors that had signal in one assay, but not the other. And it was really all about the data integration that allows you to do this early detection. So I chose this one because they were scored by everything, but that wasn't always the case. Sometimes you saw a mutation without a copy number change or a methylation change without a copy number change. And that's really why this multi-omic approach is so important within one program. So that's going to be coming out very soon. Actually, really great collaboration with Andrea Doria and the imaging group to really start to put models together, integrating cell-free DNA and imaging data. And this is actually turned into one of those team breakthrough grants that's going to switch from retrospective mode, which is what I just showed you, and flip this into prospective mode because we have the ability to return these results. So we're actually going to enroll 1,000 carriers of a variety of hereditary cancer syndromes, building on our experience with Lee-Fraumeni. 500 of them will get that cell-free DNA result back. 500 of them will get the regular surveillance. The group getting cell-free DNA results back also get regular surveillance as well. But instead of collecting blood every year, we'll be collecting it much more frequently, every 4 months. And if a signal is found, this will be returned to the geneticist, and they'll act immediately and schedule an off-cycle surveillance visit. So they don't have to wait the whole year. If we have a hint of that in cell-free DNA, and we want to know, are we able to find cancer early? And this is a tool that we could start to integrate into surveillance programs. with the added benefit that it's not necessarily centralized. So we've had contracts with Life Labs and Dynacare. So the participants can go to any of their local blood labs in Canada. They don't have to come downtown to have a scan or a more routine surveillance visit. So that's a work in progress. That's going to open in January. We took a whole year just to get all the contracts in place, but it was very effective to have a genomics platform where we could state very strongly in these applications that we're sort of a shovel ready for clinical testing. And this is where we want to go. This is my last slide. That current state, you're at risk for cancer. You get these huge relative risks based on the population. And we hear this idea of anxiety. You have a negative test. Is it really negative? Trying to really change that paradigm and get over here onto the right. You're still a P53 carrier. That's not going to change. But putting a more regular cell-free DNA test up front and then triggering that surveillance visit as needed, and moving away from these generalized population-based risks to known risks, not just for the presence of cancer, but potentially using the methylation-based assay to articulate where that follow-up test should look. Is it breast cancer? Is it ovarian cancer? And since we're doing whole genome sequencing, it fits that whole methylation whole genome sequencing. We really get a complete picture across all cancer types. So that's where we are. There's the teams. We've heard from all of our departments and our many collaborators. So really kudos and thank you to them. It's actually a really special group. If you want to learn more, our website is there. If you want to email us directly, we have our email there. But yes, happy to take questions at this point and break for lunch after that.